In this video, we'll be covering regular expressions with Python. The first thing I need to do is import the correct library, so we'll import RE. And the first thing that I'm going to do is just create a sentence. Okay, so the first thing that we're going to use is to search. So let's just create a new variable, and then we can use re.search. And we're just going to search for the string quick. And so we need to pass in two arguments. The first argument is the pattern. So the pattern is the word quick. The second argument is going to be the string of text that we'll be searching, and that's going to be the sentence. And if we go ahead and print that, we're just going to return as an object. So save the file. And as you can see, we got a regular expression match object, and it's given us a couple different things. So the match of quick, so it did find it, and the span, which is 4, 9. Those are the index values of where it found it inside the sentence string. The word quick, this is basically the start of the 4th character through the 9th character. And there are several methods that we can use once we have this. So obviously we just printed out the object. So if we want just the start, of the word quick, we can go o.start. And actually we could do the same thing for the end. And then if I rerun it, so I just got 4 and 9, so I can just save them to variables. And we can get them both as a tuple also. We can just print out the span. There's also a span method. In order to run the next couple of examples, what I'm going to do is go ahead and create a new sentence. Okay, so the next thing that we will be covering are character sets. And let's say let's just grab the first word. We want re.search. And character sets, they frequently, so what they do is take a pair of brackets. So we're going to allow A to Z. So A to Z is a range. And then if we want multiple ranges, let's say we want all the lowercase a to z followed by all the uppercase a to z. We can do that. So that is basically matching any character set for any upper or lowercase letter. And then we want the plus sign in order to, otherwise it would be just one character. So we want multiple characters. And then the second argument, we need to pass in our sentence. So we go ahead and print. If we were to print the first word, we would get the matching object again. So let's print first word .group, and then we get the first word returned to us. We can also find every single word and get that returned to us. So we'll just create a new variable for that, and we use the find all method. And so the first argument, once again, we have to pass in the pattern, and we're going to use the same one from up here. And the second argument, once again, will be our sentence. And if I save that and run it, actually we need a print statement, and we get basically a list of all the words that were in that sentence. And notice the numbers are missing. So what we told it in our pattern, we just want any lowercase or uppercase letter. So 1 and 10 are left out. So we can also do one for numbers. And what we're going to be passing in is a \d plus. So \d is like a shorthand character set for 0 to 9. And we can go ahead and pass in our sentence. And we'll go ahead and print numbers. We save that and run it. So we get a list returning back to us the values 1 and 10. Another thing we can do is, so we can return, let's say we wanted to return every single word, whether it was just a couple of number characters or regular word A to Z that consists of only letters. So let's create a new variable. We'll just call it everything. So re.findAll, and what we want is \w plus. And now it's important to note, so this is another shorthand, a little bit like \d. So \w is equivalent to, so if we were to have a character set that was A to Z, capital A to Z, 0 to 9, and it also includes the underscore. So what we could have done was use that. Well, we also need the plus to return multiple characters. And then let's pass in sentence. And we'll go ahead and print everything. And then as you can see down here, we have everything, whether it's just a regular word or even the number value. And so, like I said earlier, we can use a \w, and that should give us the same result, and which it does. Next thing I wanted to cover was negated sets. Let's create a new variable. Let's call this words only. And let's call our findAll method again. And so negated sets, what we're going to have inside of our brackets, the first thing that we're going to have is a hat or a caret. So that means everything except those. So it's kind of the opposite of the regular caret set. So what we can do here is we're going to include everything except a number. So everything except \d. And then we also have some spaces in our sentence. So we need to just include a space. So anything that is not a digit or not a space should get returned here. And let's make sure we pass in our sentence as the second parameter. And print. And what I forgot, so it gave us every single character in a list. So the reason why that happened is I did not put a plus here. So let's go ahead and rerun this. And then so we had the same thing as we had earlier. So we basically used negated sets, which gave us the same result as the words up here. So without the caret, we're including all of these. If this caret character is here, then we are including everything except for that. So the next thing that we'll be covering are word boundaries. So I'm just going to put a comment on here. These can get pretty confusing. So the word boundaries, so we have several here. As you can see, we have all these spaces. Those are considered word boundaries. If we were to have other special characters that are not A to Z, 0 to 9, underscore, like if we had like a, I don't know, like a hash or something like that, that would be considered a word boundary. So anything that is not part of this character set, part of \w. So we're going to go ahead and use one. So word boundary. And so the first thing so a \b is in regular expressions the symbol for the word boundary. However, in Python, we need to make sure that's normally a backspace character, so we need to convert that to a raw string. And we do that with an R and then following the quotes. So we want \b, and let's look for the word jump. And let's pass in our sentence. And then if we go ahead and run that, as you can see, we got an empty list right here. So the reason for that is if we look back at our sentence, so we have the word jump in here. However, it is followed by an alphanumeric character. It's followed by an E, and that is not considered a boundary. So if we copy this and we change this to jumped, we can go ahead and rerun this. And then the jumped, basically it gave us a match. And the reason for that is right after the D is a space character, and that is not in this character set. So the boundary is a requirement based on the pattern that we passed in, which is why we have a result. A common convention is to use a syntax like this. So all caps by convention. This is not something that's enforced, but by convention it means that it's a constant value. And so for a zip code, let's just say we're going to use a character. A caret. So the caret, when it's outside of a character set, meaning if it's not inside any brackets, it's at the very beginning of the regular expression. That means that it's a requirement that whatever follows it, that's what has to start. Okay, so in this example, so we need 5 numbers. And we could force this constraint by using curly braces and the number 5. So by having the caret symbol \d, meaning digit, numeric value of 5, that means it has to start with 5 numbers. Let's just call this variable zip5. And then let's set this to a value of 8999. And then we can go ahead and print our value. And let's pass in our zip pattern, followed by zip5. And accidentally press the comma twice. And so we do have a match. However, so what happens a lot of times with zip codes is there's also a zip9. So let's copy this. And so zip codes can commonly appear like that. And then what happens is if we rerun this, this one is not going to match. Actually, it did match. It matched only the first 5. So what we need to do in order for it to have a full match is we need to add 4 more. So let's make this a separate group. And each set of parentheses, we'll go into this a little bit later, is considered a group within the regular expression. And so we need \d, and then let's set that to a length of 4. And so we need a $sign at the end. A $sign means it has to end with the last 4 items, the last 4 numbers. So just to recap, a caret means that is a constraint that this must start with 5 digits. $sign is the same thing, except for it has to end with a certain set of characters. So let's save that, and what's going to happen is the first one should fail. So now that we added this we do have a match. We have a full match for 8999-1234, but our first one now is failing. So what we need to do is make the second group make this optional. And the only thing we need to do is to add a question mark. So adding this question mark here means everything in this group is now optional. So this should accommodate both of our zip codes. So if we go ahead and rerun the file, as you can see, so we have a match among the first 5 characters of zip5, and then we have the full 10 characters of a zip9. So in the next example, we're going to make an email validator. So let's just create a new email pattern. So our email pattern, so we're going to use the caret to force it to start with any alphanumeric character, and then we want to allow a period. So what we need to do is we need to escape that. So a dot has basically a meaning within a regular expression. So if we want it to be a literal value, we need to escape certain characters. And we want to allow a hyphen also. So we'll go ahead and add a plus. So one too many characters, and then followed by the @ symbol. And let's create a new set. And then inside that, we'll create a new character set. That's square brackets. So we want to allow any alphanumeric character, and then we'll also allow hyphens. Let's go ahead and escape that. And then we can have the period also. So one too many characters, and then so after the period, we can also, actually I did not mean to put the period inside the, that's for basically the domain extension, so we do not want that inside of our brackets. So we want that out here. So it's part of the set, but it's not inside the, and then we want this plus to be here. And then, so after the dot, what we want is a, actually let me escape that. After the dot, we want our domain extension. So we're going to allow any character followed by one too many, and then followed by the $sign, because so me at example.com, the .com has to end with letters for the top level domain name. So let's go ahead and save that, and then we can define a function is valid email, and we're going to take in email address as an argument. And so we can say match results. So we want re.match, so we want our email pattern followed by email address. So we're going to use an if truthy value. So it'll hit this line unless match result is none. So we want to return true, else we will return false. So we go ahead and use this. So print is valid email, and let's put in me at example.com, and if we save that and run it, so we got a true value returned back to us. And let's just take this out. We'll just give it a domain name and then save and rerun it. So that gave us a false value. And let's just do one more. Let's just go, I don't know, www.example.com. And if we run that, that gives us a false value. So this is how we can use a validator or create a validator using a function along with a regular expression pattern. And I think that's it for this video. In the next video, we will go further in depth into some more things we can do with regular expressions. Thanks for watching.